In the last part of the lecture, we'll consider some simple combined transformations. A combined transformation is the application of two or more individual transformations, such as T1, T2, and T3, and so on. The order in which we apply the transformations must be specified. For instance, T1 and then T2. Let's have a look at a graphical example to start with. In this example, we're going to transform the graph of some function f of x by, first of all, applying a vertical stretch with a scale factor of +2, and then secondly, a vertical translation of -2 units. There are two separate transformations, so we'll use two separate graphs on the right-hand side to show the results step by step. First of all then, we note that the intercept on the y-axis in f of x is 0, -2. When we apply the vertical stretch with a scale factor of +2, this will be moved to 0, -4. And when we sketch on the graph, we should indicate that the graph is bent upwards much more strongly than it was in the original function. Next, we apply T2 to T1. So T1 is the intermediate step, and T2 is the final step. Looking at the graph of T1, we have to apply a vertical translation to that graph of -2 units. So we just imagine shifting this curve downwards by 2 units. And if we do that, our new intercept will be at 0, -6. And that's all there is to it. Let's have a look at another example. In the second example, we're told that the function f of x is transformed by applying a sequence of 3 transformations, T1, T2, and T3. The end result of these 3 transformations is the transformed function g of x, which is equal to 2x squared minus 12x plus 24. T1 is translate 3 units to the right. T2 translate vertically by +3 units. And T3 stretch vertically by a scale factor of +2. What we have to do then is find the original function f of x. So we want to undo these transformations that were applied to f of x to get back to the original function. So let's have a look at how we can do that. We have g of x is equal to 2x squared minus 12x plus 24. That's the function that we get after applying the transformations. So f of x was our original function up here. We first apply T1, which is translate 3 units right. Then we applied T2, which was translate 3 units vertically. And finally, T3, which was a vertical stretch with a scale factor of +2. So after applying those 3 transformations to f of x, we arrived at g of x, which is equal to 2x squared minus 12x plus 24. So we want to undo these and get back to where we started. Let's do that. So g of x is equal to 2x squared minus 12x plus 24. The first step that we have to take here is to undo the last transformation in the sequence. So when we applied the sequence of transformations t1, t2, t3 to f of x to get g of x, when we undo g of x to get back to f of x, we have to do it in reverse order. So we have to apply the inverse of t3, the inverse of t2, and the inverse of t1. So what we'll do is to undo this, we'll start by doing the inverse of t3. So I'll just write that as t3 to the minus 1, meaning the inverse of the transformation t3. So we want to divide g of x by 2, because the vertical scale factor was 2. So to undo that, we need to divide everything by 2. So we'll divide each term by 2. So we'll get x squared minus 6x plus 12. The next step is to apply the inverse transformation of t2. t2 was to translate vertically by plus 3 units. So in order to undo this, we need to shift down, translate down by 3 units. So when we apply that, we'll get x squared minus 6x plus 9, which we can write as x minus 3 all squared. So after applying that, let's just write that out again, x minus 3 all squared. Lastly, we want to undo t1, so we'll write that as t1 to the minus 1. Now remember, when we applied t1, we had to translate 3 units to the right. So the inverse of that is going to be translate 3 units left, or add 3 inside of the function brackets. So the inverse then will be x minus 3 plus 3 all squared. So therefore f of x will equal x squared. Now have a go at the multiple choice question.